Sir?
Thank you very much for the brief introduction because, as I told you, my material will be running for about at least 1 hour, 15 minutes. If I'm not able to conclude, still I have the supporting text material that will associate, that will be, given to every student. And therefore, I will try to cover as much as I can. Let me start this session. This session is on deep learning for cybersecurity. You have heard enough on cybersecurity. The cybersecurity in conventional techniques, with conventional techniques, it is not, they are not able to combat the modern challenges in cybersecurity. So machine learning comes into the help. Even in machine learning, deep learning is a special field which is being used by the industry for combating the latest challenges in the field of cybersecurity. Since this department is offering both data science and cybersecurity, we were able to combine both. And my focus will be on how data science, so to say, deep learning. I'll start with the beginning. This lecture is organized as a self-contained lecture. If you go through my material, you will be able to get from A to Z, even if it's not in detail, in nutshell, so that from there you can capture the other threads. I organized my lecture in this perspective. So let us get into the. So the objective of deep learning for cybersecurity. My aim is to disseminate more knowledge in data science that can be used to solve daunting challenges in contemporary cyber world. Next point is to bring more people to data science and cybersecurity, the frontiers of emerging technologies. To review what is cybersecurity problem and what are the typical basic controls we do to get into the machine learning, followed by deep learning, then into deploying deep learning for cybersecurity in an effective manner. So as far as the machine learning as a tool for cybersecurity, I will introduce each and every piece of machine learning right from the beginning in a lucid manner, so you can pick up the thread and move further. Okay. So we have a lot of tools for cybersecurity. You heard enough in all these 12 sessions. Mine is 13, like firewall, antivirus software, PKI services, managing incident detection and intrusion and response services, network security monitoring tools, encryption tools, vulnerability on web scanning tools. Okay. Network defense wireless tools, packet sniffers, machine learning tools, all these things for all the 9 components. Machine learning has become an additional technology for making a firewall, for making an antivirus software, for enabling PKI services in a better way, to do MDR in a better way, to do network monitoring in a better way, to do encryption in a better way, reducing vulnerability in web in a better way, for all that. So machine learning has come into every aspect of cybersecurity. So naturally, ML, the so-called machine learning, preemptively stamps out cyber threats and strengthens security infrastructure through detecting security patterns on real-time cyber crime mapping and in doing thorough penetration testing. You may be wondering, is machine learning is enough to stop cybercrime? Definitely not, but it will help you more. What is more important is AI itself is not immune to attacks. As we use AI, machine learning, for combating cybercrime, the cyber criminals also, they use machine learning. So the use of machine learning for cyber attacks remain continuous techniques, and we need to be much more smarter. So machine learning is not enough to stop cybercrime very clearly. So how ML will help cybersecurity? From that point of view, it will help us to find, threats on a network. Okay, so how will it find threats on a network? It detects threats by constantly monitoring the behavior of the network for anomalies. That is semi-automatically done previously. Now ML is deployed. ML engines will process massive amount of data in real time, near real time, to discover critical incidents. These techniques allow for detection of insider threats, unknown malware, and policy violations. If any, you have your security policy, if there is a violation, it will the automated ML engines will help tell you. It will keep people safe when browsing. How? It can predict bad neighborhoods online to help prevent people from connecting to malicious websites. Machine learning analyzes internet actively all its activities to automatically identify attack infrastructures staged for current and emerging threats. This manually is not possible. Next is it provides endpoint malware protection. Algorithms can detect never before seen malware that is trying to run on endpoints. You have seen edge security, all that. Okay. It identifies new malicious files and activity based on the attributes and behavior of known malware. It protects data in the cloud. That too. Machine learning can protect productivity by analyzing suspicious cloud app login activity, detecting location-based anomalies. I'll tell you what location-based anomalies. Suppose a customer is used to log in all the time from 2, 3, 4 locations. Suddenly, the logging in location changes. Now you might have seen in mail applications. If you are logging in from a different location, different device, mail server will say, "Is it you?" It may send an additional OTP to your mail and check whether it is you. So all that. So how does it check? This is again through automatic machine learning. It is having your location details. So you are, say, for instance, suppose you have your money transaction patterns. You might have subscribed to 2, 3 systems. Maybe on a monthly basis you pay for your newspaper, you pay for your this and that. There are n number of items you pay through net banking, and your payment pattern normally from 1 to 10 of a month, the days from 1 to 10 of a month, and to particular destination. If it is suddenly changing, then it will sense it. It will sense it and ask for an additional detail. So these are all, machine learning can very well do it. And where these are additional security. So it will, analyze the suspicious cloud app login activity, detection location-based anomalies, and conducting IP reputation analysis to identify threats and risks in cloud apps and platforms. Detect malware in encrypted traffic. Machine learning, normally when a data moves in an encrypted traffic, when a malware is inside, as far as machine learning is concerned, it is detecting patterns, and therefore it will be able to check those patterns which are normally in the normal system. It is not possible. So it will be analyzing the encrypted traffic data elements in common network telemetry. Rather than decrypting in the encrypted form itself, ML algorithms will pinpoint malicious patterns to find threats hidden with encryption. This is a very special capability of machine learning. So what are some of the applications of supervised machine learning in cybersecurity? There are umpteen applications, but by using predictive analytics to detect threats and malicious activity, using natural language processing for security, enhancing biometric-based login techniques, cyber threat identification, AI-based antivirus software, user behavior modeling, fighting AI threats, email monitoring. All these things are very much possible. Some of the very vital applications. So, by the way, let us know what is. So far, I have been using machine learning without defining what machine learning is all about. We will get into the bits and pieces. The so-called ML machine learning will allow computers to learn without being explicitly programmed. This is where we digress. What we learn, the human learning and machine learning, an analogy of human learning is transferred to machine. Okay, put it another way, the machine learning will teach us the computer to do what people normally do when we learn. Say, for instance, in the 80s, we had only 2-3 types of cars in our field. One is Maruti 800 and Ambassador, and 1 or 2 variants of imported cars. Not many, maximum 3 or 4 types. And when new things came, new cars came in, people have identified whether this entry level, mid segment, luxury type, and then super luxury, all that. As more and more cars came in, and when a new car is marketed and you know about its feature, you can fix whether it's an entry level or advanced level, super luxury, Audi car, or Rolex, whatever. So by adding more and more data to your system, and you are able to predict the same capability using data. It is algorithms normally will ask you to do a number of steps when you compute step 1, step 2, step 3, like that. It will computers normally we say when we teach algorithms, computers will only do what it is instructed to do, but it will not do what you intended to do. That is broken in ML. ML, the learning capability, when it is taught to the computer, it will keep on continuously updating its data. It learns from data and interprets data and classifies data. Let us see how it is. Okay. So the for doing this, using data learning, so-called artificial intelligence, ML learning is machine learning entry level. It has got 2 categories: supervised machine learning and unsupervised machine learning. So, as I told you, ML learns from data, typically called supervised machine learning. This is the type of machine learning in which machines are trained using well-labeled training data. And on the basis of that training data, machines predict the output. The labeled training data means some input data is already tagged with the correct output data. So we already know this is the input, this is the output, this is the input, this is the output. For 3, 4, or 10, 15, 100 categories we have, if this is the input, this is the output. This input-output pair we know. Okay. Using this input-output pair, like we know some 10 types of cars. Then we classify a new car which is not coming under this, and trying to match which is the nearest category, entry level or mid level or luxury, like that. Okay. In supervised learning, the training data provides to the machine work as a supervisor, similar to that teaches the machine to predict the output correctly. It applies the same concept, similar to a student learns from a teacher. So supervised learning is the process of providing a set of input data and the corresponding correct output data to the machine learning model. So it will, using this data, it will make its own model. And supervised learning is the machine learning task of learning a function. So once the model is available, it makes, okay, if a data comes, it can categorize them into one of that. So it maps the input to an output based on example input-output pairs. So this training process is how, suppose we have 100 data. input output. This is the input, this is the correct output. Out of the 100 data, we will earmark 20 or 30 for testing. We will train the computer using 70 pairs, input output pairs. We will train the computer. And then use these 20 or 30 test data to test whether the computer has machine learning has happened. So if given the test data, here also input output, correctly, this is the input, this is the output. If this is without telling the output, the input data alone is given. If the model is correctly classifying, finding out the result, then it has learned. Then an unknown thing comes, it may probably map it correctly. That is the understanding. Okay. So supervised learning, the training data provides the machine. Yeah, it will act as a supervisor that teaches the machine to predict the output correctly. So supervised learning is a process of providing a set of input data and the corresponding correct output data to the model. Okay. Now, the aim of this supervised learning algorithm is to find a mapping function. Generally, if a data is given, to map the unknown input variable with the correct with some output variable which is probably correct. It infers the mapping function from the labeled training data set consisting of a set of training examples. The plus point of supervised learning is it allows you to collect data or produce a data output from the previous experience. The limitation or minus point is that the decision boundary might be overstrained if your training data training data set doesn't contain enough examples for finding out all types of inputs in a class. So there will be cases where we may not have the correct input, correct output training pattern. For that, another technique is available that is called unsupervised machine learning. When we do not have labeled data to train, it will use try to extract patterns from the data and then try to classify according to the pattern. Okay, so unsupervised learning techniques where models are not given any training data set. Instead, model itself find the hidden patterns, insights from the given data. It can be compared to learning, which takes place in human brain by known by examples itself. So unsupervised learning is a machine learning in which models are trained using unlabeled data set and are allowed to act on the data without any supervision. The goal of this to find the underlying structure of the data set, group that data according to similarities or some properties, represent the data set in a compressed format. Suppose the unsupervised learning algorithm is given an input data set containing images of different types of cats and dogs, for instance. The algorithm is never trained upon the given data set, which means it doesn't have any idea about the features of the data set. The task before unsupervised learning algorithm is to identify the image features on its own. And unsupervised algorithm will perform the task by clustering the image data set into the groups according to similarities between the images. Now you look at this. You have, in the input raw data, where you have, a set of puppies and cats. So looking at their structure, features, okay, patterns, this unsupervised algorithm will interpret it and process it and correctly identify what dogs and cats are. Sometimes, they will work. Sometimes there will be confusions. How to remove all that? I'm just telling you it's a superficial, oversimplified model. If this works, why we should have a supervised model? So there are limitations in unsupervised mechanisms, but I'll tell you unsupervised models are also used, and for for data set for to which you don't have any clue. In that case, you have to go for unsupervised and try to find patterns out of it. And for unsupervised learning algorithm, you have clustering and association, two predominant methods. They are the two popular methods. So as far as this example is concerned, the unlabeled input data is fed to the machine learning model in order to train itself. First, it will interpret the raw data, find hidden patterns from the data, and then it will apply suitable algorithms such as k-means clustering or decision tree, etc., etc. They are all the algorithmic tools. Once it applies the suitable algorithm, the algorithm divides the data object into groups according to similarities and differences between the objects. So let us look into what clustering is. Clustering is a method of grouping the objects into clusters such that objects with most similarities remain into a group, and as less or no similarities with the object of another group. So it will be, clustered. Cluster analysis finds the commonalities between the data object and categorizes them as per the presence and absence of those commonalities. Whereas the next one, association, is it is trying to find relationship between variables in the large database. It determines the set of items that occurs together in the data set. So like marketing strategy, such when people buy a bread, they also buy butter, jam, etc. This, along with bread data, you can associate butter and jam. And that is what association is all about. And what I am giving you are all very simple because I need to brush through all these things and go to deep learning. So popular unsupervised learning algorithms, they are k-means clustering, k-nearest neighborhood, hierarchical clustering, anomaly detection, neural networks, principal component analysis, independent component analysis, a priori algorithm, singular value decomposition, SVD model. They are all popular unsupervised learning algorithms. Now, in supervised learning, models are trained using labeled dataset, where models learn about each type of data. Once the training process is completed in the supervised learning, the model is tested on the basis of test data, and then it predicts the output. So the supervised learning we have seen with the labeled data, model training, prediction, all that. So let us look into supervised learning algorithmic process. We will decide the type of training data set. We gather the label training data, split the training data set into, supposing you want to put it as an algorithm. So these are the steps. So split the training data set into training data set, test data set, and validation data set. So you decide the input features of the training data set. It should have enough knowledge so that the model can accurately predict the output. This is very, very important. And how you decide that will decide the success of your learning process. Decide suitable algorithm for the model, such as support vector machine, decision tree. So you need to gain knowledge about all these techniques. Then you execute the algorithms on the training data set. Sometimes we need validation sets as the control parameters, which are the subsets of training data sets, which will have more edge fixing, and evaluate the accuracy of the model by providing the test set. If the model predicts the correct output, because you know that this input, that is the correct output, which means our model is accurate. So this is the process of algorithmic process of supervised learning. And for supervised learning, we have two techniques. If it is a numerical based one, we use regression. Regression algorithms are used if there is a relationship between input variable and the corresponding output variable. And So prediction such as weather forecasting, market trends, they are all, you know, market trends up to today. You will try to predict for future. They are all, you know, using the regression methods. So regression methods, again, linear regression, regression trees, non-linear regression, Bayesian linear regression, polynomial regression. I'm not going into the details of this because, you know, we are time bound, and I'm just telling you these are the methods. And don't get frightened by so many tools on this. All these tools are already well defined into a set of libraries, and Python is having a wonderful, you know, library set for neural networks or whatever you mentioned. I'm going to tell about in few minutes. So you need to know how it functions. If you know the mechanism or the working mechanism of tools, you will be able to choose the tool. You don't have to reinvent the wheel and then write a program for linear regression. Just you call the function linear regression, give the correct parameter, it will give the output. You have the data, you should know there is an algorithm called the linear regression is available. There is a method called regression tree is available. So what it does, what it cannot do, what it can do, what it cannot do. All these things you should know. Bayesian linear regression, what it can, what it cannot. So if you know the mechanism, for that you should know what it does, how it does, in knowledge of that. You need not have to program. Many things have gone into, you know, in fundamental library blocks. And next, coming to classification. Classification algorithms are used when you want to, you know, process the categorical data, which means whether it is yes or no, whether it is male or female, or true or false, or among a set of animals, say n type of animals, you want this first type, second type, nth type. It may not be 2, it can be 3, it can be 4, it can, but it is a categorical. That type of analysis, you need a classification. So coming to cybersecurity, the cyber threat landscape forces organizations to constantly track and correlate millions of external and internal data points across their infrastructure and users. It's simply not feasible, okay, for managing this voluminous information with only a handful of people. Okay, that is where we need all these techniques. Okay, and machine learning. It will recognize patterns and predict threats in massive data sets, all at mission speed. In cybersecurity world, supervised learning can be used for risk assessment, threat pattern classification, fraud detection, spam filtering, all that. By automating the analysis, cyber teams can rapidly detect threats and isolate situations that need deeper human analysis. So, which machine learning technique is used to perform prediction in cybersecurity? Okay. And the most popular supervised learning technique, classification and regression method. So these techniques are popular to classify, predict the future for a particular security problem as well. How does it work? Supervised learning, please recall, this is very, your understanding of supervised learning is very, it's as far as the security is concerned, I use a different terminology. It calls for on a set of training data called a ground truth. If this incident comes due to this pattern, we call it as a ground truth, which are correct question and answer pair, like input-output data. It is a ground truth. This training helps security classifiers. They are the workhorses of cybersecurity ML analysis to accurately categorize observations. Using these algorithms, we organize and orient security classifiers, successfully analyze new data in the cyber world. This is how this machine learning helps us in cybersecurity. An everyday example, for instance, you have umpteen number of online photos. Security classifiers analyze the data patterns that are trained. They don't look at noses and eyes. It is tagging, to tag a unique face among millions of online photos. It's not looking at noses or eyes, but it is looking at the pattern. Okay. So in cybersecurity, this ML continuously learns by analyzing data to find patterns in this, to do better detection of malware in encrypted traffic, find threats, predict where bad neighbors. All that is done using patterns, not just the features will be transformed. Okay, so so ML has become a vital technology for cybersecurity. It is helping us to preemptively stamp out cyber threats. It strengthens security infrastructure through pattern detection, real-time cybercrime mapping, and through penetration testing. The advantages of supervised learning is, you can use your prior experiences to class. Suppose some cyber incident happens, it comes due to this, so you can map. If this comes, this threat is there, this vulnerability is there, this attack happens, this is the consequence, you can map. And in supervised learning, we can have an exact idea about the classes of objects. That suppose we don't have, then we go for unsupervised. The limitations, this is a limitation of supervised learning. When you have your complex tasks, it may not be able to address. So a lot of computation time it needs, and we need to have enough knowledge about the object. These are the limitations. So in order to overcome the limitation of supervised learning, we deploy deep learning. I'm coming to deep learning point. So in machine learning, we use input. We use either classification or decision tree, that type of input output pair mapping, and see whether it's a car or no car. In deep learning, you don't give such training data sets. Here, the input data is given, it extracts feature, not one feature, but many features, and then classifies, and correctly classifies, gives the output. That means this is more, when complexity is involved, and more complexity they are involved, then we look at deep learning. So it is deep learning is an AI function imitating the working of human brain in decision making by creating patterns in it. So it's a subset of AI. Deep learning is a subset of AI that has network. That deep learning networks, AI networks, they are capable of learning unsupervised from data that is unstructured or unlabeled. So you don't have to have any data should be given in any structured format, in this tabular format. It can be any unstructured data. Deep learning it is using neural learning for processing its network. So technically the working is similar, but capabilities wise they are superior. It is inspired by the functionality of human brain, which are called neurons, and the concept of artificial neural networks are based on this neuron functioning. So deep learning models use different layers to learn and discover insights from the data. So each layer, it will analyze one particular feature, then combine, make bigger, then it classifies correctly. So in deep learning, don't say that always it is unsupervised. It's not like it can be, some supervision can be given, some known data you can train, semi-supervision, unsupervised, all combined. So it is non-linear. Since neural networks imitate human brain, deep learning also is a multi-layered neural network. That is the heart of deep learning. It is nothing is programmed explicitly. It's a machine learning class making use of numerous nonlinear processing units to perform feature extraction, followed by transformation. The output from each preceding layer is taken as input by each of the successive layers. And there could be some feedback also. There are different techniques of neural network for deep learning. They are capable of enough to focus on the accurate features themselves by requiring no guidance from the programmer. But here again, you don't bother much. There are so many techniques. How are we going to program each bit and pieces? Many things have come into deep learning. They are all available as tools. When learning phase, you should know what each tool is capable of doing. That is what we are learning. Okay. suppose, I know how a table is made, how a chair is made, which material, what dimension, how it is cut, where it is joined. If you ask me to do that work, I will not be, because I am not skilled enough to do that. But I can say you can use this with this. So somebody has done the building blocks as libraries for you, but you should know for what. Using a cutter, you cannot break a big rock, right? Cutter for a wood. So you should know where it will work, where it will not. For that only we are learning. So deep learning is implemented with the help of neural networks, and the basic idea behind motivation of neural networks is the biological neurons. So, and the hidden layers. So let us look at this deep learning. As I have given, several images of faces, and it is identifying correct faces. So the input layer is the raw data is given, and here it is two hidden layers are shown. One is face features, another is composing from the face features to the face. But there will be actually the hidden layers will be many, depending on the number of features, number of things you would like to, nitty-gritties you would like to extract. So you can deploy several hidden layers in between, and the output layer will give the correct output. Okay, so look at this example. The raw data of face images, the first layer. The input layer will decide the patterns of local contrast. That means it will differentiate on the basis of color, luminosity of the image. The first hidden layer, it will determine the face features. It will fix it on eyes, nose, and lips, and it will fix those face features on the correct face template. The second hidden layer, it will actually determine the correct face, after which it will be sent to the output layer and correctly identify it. So you can have n number of layers in between to have more complex problem. So for all that, the basic brain is a single neuron. How the single neuron computing is working. You have a set of inputs for each x1, x2, xn. Okay, the working of this single neuron is very, very essential. This set of inputs to the neuron, they are x1, x2, xn. And for each of this input, they are having different weights, w1, w2, wn. All weights need not be equal. Depending on the weight is given, you can, each input and corresponding weight, you multiply them and make a sum. So sigma xi wi is one thing which is non-linearly, linearly looking at different features with the different weightages. Then you apply a non-linearity into that using an activation function. It gives the correct output. So with these inputs and weights, you multiply them with take a summation sigma xi wi. With that sigma xi wi, which will come as a single number, you pass it through a non-linear activation function to produce the final output. So in the X also, we can add a bias that I have missed it. Okay, you can add a bias W0. Okay, and the bias will be added to the sigma xi wi prior to you are applying this non-linear activation function. Okay, so non-linearity, how it is making. So what is the role of this bias? It will actually shift your activation function to the left or right regardless of the inputs. So that bias is not affected by the inputs. It is just a bias associated that associates that input. It can either shift left or right. For that only bias is used. So actually the activation function introduces the non-linearity. Mathematically, the above diagram is represented mathematically here. You look at it. This x can be represented, the set of x values x1 to xn. It can be represented as a vector x. Weights can be vector w, and your bias plus the summation xi wi can be represented as x transpose capital X transpose w, On that, you apply the activation function G. And so your Z is, if you are representing the bias W0 plus X transpose capital W, capital X transpose capital W as Z, your activation function is G of Z is defined as a sigmoidal function 1 by 1 plus e power minus Z. That makes the non-linearity, the summation of all inputs, okay, is subject to this on a activation function G. Okay, so if you don't let us, it's not only one, sigmoidal function is not the only activation function. You have tan H, softmax, rectified linear unit. They are, few more nonlinear activation functions. Let us find out if these nonlinear activation functions are not there, what will happen to our input. Say I am giving an example. Okay, limitation of linear activation function. This first graph is having a set of green and blue dots, and they are scattered. Supposing without the activation function, you have this spot alone. It will have a straight line like when you fit the straight line. Okay, this straight line predominantly classifies, okay, on the top side of the straight line, green dots, and below that blue dots are there. But still many green dots are there below. You can only draw a line where it is more, where it is less. This is the linear attempt to separate the points. Suppose you have a non-linear attempt, then it will try to cover the maximum number of blue within the boundary and exclude all greens outside the boundary. This is the beauty of non-linear. So non-linear will always solve complex problems, because linear will, at the best it will give you a straight line. So you can go through that. If time permits, I could have given more into it, because I have more to cover. So many such single neurons are combined with this activation function, nonlinear activation function, into a neural network. So this is how many such single neurons combined together, single layer neural network is formed. And so I am rushing up, but don't bother. My reading material has got the full details on that, because I have to fairly cover more on cybersecurity too, where it is fitting. I should not miss deep learning. At the same time, I should also connect cybersecurity to deep learning. So, so knowing the design of deep learning algorithm. So let us spare some time on this. Deep learning is a method of subset of AI imitating the human action and brain function. Okay. In data science, deep learning is a very important element, and it is running based on data-driven techniques used under predictive modeling and statistics. Predictive modeling and statistics is very, very, central to deep learning, where we predict. Deep learning algorithms are dynamically made to run through several layers of neural networks, which are simply a set of decision-making networks that are pre-trained to serve a task. Later on, each of these is passed through simple layered representations and move on to the next layer. So most machine learning is trained to work fairly well on data sets that have to deal with hundreds of features in the column. So you'll have many hidden layer feature sets. For data set to be structured or unstructured, machine learning tends to fail mostly because when you have less complexity, don't use deep learning. For that, you have machine learning. So, so you need, it's like for killing an ant, you should not look for a big hammer. So importance is it plays a crucial role in determining the features and can handle the large number of processes for the data that might be structured or unstructured. Deep learning algorithms can easily crack tasks that might involve complex problems requiring analysis to huge amount of data effectively. In cybersecurity, we are dealing huge amounts of data, especially in the post-pandemic. We have, scattered across the globe. So deep learning is an inevitable tool for us. So consider ImageNet. That is applying this. ImageNet is a popular deep learning tool. It recognizes images that has access to 14 million images. Remember, in a data-driven algorithm, it's highly a comprehensive tool that has defined next-level benchmark to deep learning tool. So such complexities are possible because of the computing power we have through cloud model. Even for doing many deep learning testing and all, Google, has got lot many free online facility. Python, Google Colab, and there are so many tools available with that. You can do that with a call, give the right input. But you should know what right input should be given. For that, you should know what this neural network, deep learning, how it works, what are the tools it uses. Only then you will be able to use it. Okay, they are highly sensitive to detect low-level features like edges, pixels, and henceforth they combine layers and take information and form a holistic representation by comparing it with previous data. So in the middle layer, for example, it might be programmed to detect some special parts of the objects in the photograph, which other deep trained layers are programmed to detect special objects like dogs, trees, utensils, etc. So, deep learning, you use it for nonlinear type of problem. Don't use it for linear models, and it may not fit in. So deep layer architectures involving deep neural network. Deep neural network is a neural network incorporating the complexity of a certain level, which means several numbers of hidden layers are encompassed in between the input and output layers. They are highly proficient model and they process nonlinear associations. Okay, deep belief networks. That is a class of deep learning, deep neural network comprising of multi-layered belief networks. So steps to perform DBN. With the help of, yes, we are approaching one. Can I take 15 more minutes because I need a, if you are question answer session, we are not able to, if you are not able to spare more on that, still you can pass the question through my mail and all, but I would like to, complete this with all the material I have. Definitely, this video will be shared in YouTube. It is available, it will be available in YouTube, and the text material, associated with this presentation, having a complete write-up will be given to you. So don't bother. But hearing is, you read a text. The text is written not just a textbook fashion. It is for the presentation fashion. So I have prepared and written the text. Then I prepared the PPT, what to put here and all. Therefore, many things are in my, 90% what is in my mind, I have put it in the text. So combined together, it will be a good, combination. So whatever is left, I try to cover. Okay. So you have recurrent neural network. This will permit parallel as well as sequential computation, and it exactly similar to that of a human brain. It is capable of recalling the essential things related to input they have received. It's more precise. So there are 5 prominent deep learning networks available to us: feed-forward neural network, recurrent neural network, convolution neural network, and restricted Boltzmann machine, autoencoder neural networks. So the neural networks are, all these variants are given in a nutshell with, a lot of, this side, the details on this. For every legend, the details are given. The backfed input cell, noisy input cell, hidden cell. These are all explained well in each of these methods, and all these neural network models are available as library tools. But then essentially you should know what it does, what it does not. Only then you will be able to use them for your research. You don't have to start your research from scratch. Especially in cybersecurity, if you fix one or two, it will be a good contribution, because many people are doing parallelly, and you can write your blogs. Know things when many things are bundled into library. Still, you need to get the insight of that, what it does. First, find out what part of any knowledge. If you need that particular tool, then you go into the how part of it. So feed-forward network. This is the most basic network of artificial neural network. So all the perceptrons are organized within layers, such as the input layer takes input and the output layer generates the output. Since the hidden layers do not link with the output layer, they are named as hidden layers. Okay. Each of the perceptrons contained in one single layer is associated with each node in the subsequent layer. Therefore, all the nodes are fully connected. If you look at each node, it is connected with every other node. It may not be there for all models, but this model, feed forward, it is like that. Okay. So there are no back loops in the feed forward network. Okay. To minimize the prediction error, the backpropagation algorithm can be used to update the weight values. That is an add-on things later on. Okay. Application of this feedforward network: data compression, pattern recognition, computer vision, sonar target recognition, speech recognition, handwritten character recognition. For all that, it can be used. The next type of neural network is recurrent neural network, under which you have two LSTM neural network, that is long short-term memory network. For want of time, I'm just skipping this. I just name. And the second is LSTM based recurrent neural networks. These two are used interchangeably. Okay. This recurrent neural network has got two variants. First is a long short-term memory network, and LSTM based recurrent neural network. I have given explanation for this in my text material. Let me skip for a while. Okay. So the what is the time? 1. Okay. Let me, because cybersecurity tools I need to cover. So convolution neural networks. So convolution neural networks, this is a special kind of neural network mainly used for image classification, clustering of images, and object recognition. So CNN, that is popularly known as ConNets, several layers are used here specifically for image processing and detection of objects, and they are used to identify image of satellites, medical image processing, series forecasting, and anomaly detection. Anomaly detection is for cybersecurity. CNN is processing data by passing it through multiple layers and extracting features to exhibit convolutional operations. And a convolution layer consists of a rectified linear unit that outlasts to rectify the feature map. There is a pooling layer to rectify the feature maps into the next feed. Pooling is generally a sampled algorithm that downsamples it and reduces the dimension of the feature map. Actually, this has got so many number of features. It is downsampled, convolved with the rectified linear unit. Again, it goes to another max pool and then fully corrected. Okay, then it is fully connected and output is it is a cater. So downsampling where it will to reduce the dimension it is used. Application is to identify faces, street signs, tumors, image recognition, video analysis, drug discovery, and time series forecasting. All that this can be used. Okay, and I'll just skip deep belief networks and restricted Boltzmann network. I have given all details, auto encoder, all that I have given. So for want of time, because I have to cover the other two very, very important. Let us straight go to deep learning applications. Self-driving cars. How a self-driving car works? It is able to capture the images around it by processing a huge amount of data, and then it will decide which action should be incorporated to take a left or right or center, so that no accident happens. It reduces. So it does a lot of feature extraction on that. Voice controller controlled assistants, which you are all familiar. Okay. So Siri is one very, very familiar, very much familiar application, and it will it will search it for you and display it for you. Automatic image caption generation. Whenever an image you upload an image, the algorithm will work in such a way that it will generate captions accordingly. If you say blue colored eye, it will display blue colored eye with a caption at the bottom of the image. Automatic machine translation will be able to convert one language into another with the help of deep learning. That is used left and right nowadays. Limitation, it only learns through the observations. Comprises of biases issues. Advantages, need of future engineering, eradicates huge costs that are needless. Easily, it identifies difficult defects in datasets. The best in-class performance on difficult problems. It requires for applying, deep learning, you require ample amount of data. It's quite expensive to train. Doesn't have strong theoretical groundwork, but it has got non-linearity and it works with a lot of machine power available, computing power available. The key aspect is it is used primarily for detecting objects, recognizing speech, translating languages, and making decisions. So without human supervision, it can handle unstructured and unlabeled data. And very important thing is we have a known neural network library, Keras. Please note it down. It's an open source high-level neural network library, which is written in Python, capable of running on TNO, TensorFlow, and CNTK. It was developed by one of the Google engineers, a French person, Collet. It is made user-friendly, extensible, and modular for facilitating faster experimentation with the deep neural networks. It not only supports convolution networks and recurrent networks individually, but a their combination also. So now, we'll come to the main point. Okay, I'll take another 10 minutes on this. Looking at deep learning for cybersecurity tasks. So my aim is to bring more and more people to data science as well as cybersecurity. So what is the cybersecurity problem and what are the typical basic controls we employ in cybersecurity, and where this deep learning comes into. Talk more about from a security, data science and machine learning point of view. We'll get modern era has broken traditional cybersecurity parameters. We all know that traditional cybersecurity parameters are well put into pieces. If you talk about an organization, it's actually having a lot of offices. It has a headquarters, many regional offices, office data center in multiple cities. So, somehow with the network segmentation and with firewalls, intrusion and detection systems, you could integrate them into information system. We are able to manage their perimeter and we are able to do the network control. But that is broken now into pieces. We got mobiles, IoT devices, users shuffling between various workplaces, various places and various devices. Therefore, you can't really control where the user is going to be, in which kind of network he'll be working. Right? If he's going to an airport, he'll be using the airport Wi-Fi. If he's sitting in a coffee shop, he'll use the Wi-Fi there. And everywhere some vulnerability is there, and that is wide open. There is no security operations center nowadays. So
yes, sir. Now it's perfect, sir.
My screen is seen?
Yes, sir. Perfect, sir. Now perfect, sir.
Okay. Sorry for all these glitches only. I insist that the resource persons give the recorded video in case we are not able to get their connection. It happens. Okay. Actually, the list secure more is much more than what is listed. The topmost should be the user security, bringing the awareness among users. So it's a tough situation. You think security at various layers, it becomes even more complex. So from the defense point of view, using a lot of security controls, okay, the cybersecurity problem, a lot of security controls, your boundary firewall and internet gateways, malware protection, patch management, whitelisting and execution control, secure configuration, password policy, security policy. Password policy is one of the security policy, and user access control, incident management. So if you talk about any incident response, and if you talk to the chief security officer, he will say that first you have to have the basic security controls, and this is what it means, the basic security. So putting for these security controls, you need to have a firewall, the IDS called intrusion detection system, intrusion prevention system, basic controls for the perimeter, then something for the malware, something for the endpoints, some way to do your whitelisting, some way to do your vulnerability management, all these things for user access control. And everybody in an organization, not everybody should have a control. What is required, what is supposed to do, what is not supposed to do should be known to everyone. So the control access should be crisply defined, and the configurations are well secured. So these are the various aspects of the basic controls and has to be done first. So these are the basic foundations of security that has to be done. But beyond that, we need to look at the evolution of security data science. See, in early 90s to 2000, the first decade, you had a rule-based anomaly detection. Then, organizations' boundaries were well defined. So rule-based anomaly detection with the firewall, everything was fine. And between 2000 and 2005, we were all, enthused to talk about data mining-based anomaly detection. That was considered to be a breakthrough. And then machine learning came into supervised, unsupervised learning, and user behavior analysis, malware classification. All this we talked for another decade between 2005 to 2015. 2016 onwards, we talk about many things in deep learning using threats which we have never seen before. So if you look at the security data science in 2001 and beyond, 2021 and beyond, deep learning is all your life. Okay, where do we get this security data sources? Okay, remember in the criminal law, they say that any criminal will leave a trace at the site of a crime, and the job of the police and the investigators, okay, is to find out that trace or the traces left behind by the criminal. But understand, in cyber world, you cannot do anything without leaving a trace of your action. Somewhere it is logged, somewhere it is recorded. Then why we are not able to find out the cyber crimes? They say that human crime, the physical crimes are easily tracked and they are able to nab the criminal. Why cyber criminals go scot-free? Because the cyber criminals, they do in very small quantum. Now, that's not the real problem. The real problem is the volume. The real problem is the volume of data that has to be handled and the types of problems that has to be defined, though we have everything is logged into the system. Okay. So this security data sources, they are the massive data sets. They will run into zettabytes nowadays. I have this written 1 year back. It will easily run into a few zettabytes nowadays, data per day. And your network logs, firewalls, intrusion detection system, intrusion prevention system, network flow, your domain name system, Wi-Fi, they are all coming under the network logs. Your authentication log entries, Windows events, Active Directory user logs, privileged user, okay, that has got terabytes of data in that. Endpoint logs, file system changes, application logs, process logs, operating system logs, antivirus alerts, they all have, okay. And application security is one level, user security is another level. So everywhere when transaction happens, the trace is recorded. But how to collect those data and put the pieces together, form a holistic viewpoint of the cyber crime or cyber incident or prevention or policing or ensuring security or ensuring authenticity, ensuring CIA, confidentiality, integrity, and availability, this triad. Putting all these, data logs, they are, innumerable in volume, in size. For this security data sources, you cannot do without data science called, deep learning methods. Because humanly, this, tracing all these things are next to impossible. Okay, so all these data sources will start with the form of logs. If you start doing analysis on it from security data science point of view, one of the challenge would be for raising anomalies. How many controls you have to monitor? See, all these things you have to decide. See, all the logs are available. If your problem doesn't need a log from a file system changes, you don't have to use, crack those data. So you have to define how many controls you have to monitor. That is, how many endpoint logs one need to raise and maintain. If you start logging those, that will be again a huge data set. File system changes, application and process, OS logs, authentication logs, Windows security logs, etc., etc. They are all used for security, but for a specific purpose, which combination is required? They certainly capture the signal of what adversity is doing and where the threats are. But signal is too less and the noise is too much. The problem is highly skewed. Signal to noise ratio, if you come to cyber security, the it is like finding a small nut in a big ocean. Okay, like so our signal is 99 point. Noise is 99.9999. Your signal is epsilon quantum. To find out the signal, that is the security problem, you need definitely the deep learning. Okay, so you will not be able to do by machine learning. You will not be able to label everything, right? So you need to have much more complex deep learning use cases. Okay, and learn from them. Okay. So network security means network intrusion detection, scanning, spoofing, etc. Application attack detection. Look at the top 10 attacks. You have to go through the literature, find what happened, and then learn more about it. So cyber security expert job is not that simple. You need to be knowing what data science is, all that. Without that, you can't do cyber security. Phishing attack, malicious URL detection. If you come to endpoint security, malware detection, classification, spyware, ransomware detection, the authentication use cases, user behavior analytics, detection of suspicious sign-in activities, brute force attacks, and infected devices. I'm very sorry to inform you that what are all we have seen in 9 sessions. 12 sessions about traditional methods. They are all needed for knowing the current scenario. Current scenario, you cannot do anything without data science and deep learning. And therefore, it's not that you need to be a data scientist, but you should know what data science does for you, where you can use data science. If you don't know the power of data science, you will not be able to demand and solve your problem. Okay, you are a security officer, cyber security officer of a particular organization or a team. No single individual is there. If an incident happens, so you will have to do the recovery, ask for, if you have in-house expertise, you do that. Otherwise, you call for the external expertise. You need to apprise them with the correct input. For that also, you should know data science and where it is collected, and looking at your auditing, periodic auditing, where the holes are, to plug it, where to put ML type of solutions, where to put deep learning type of solutions. So data science is, and to be precise, data analytics is part of cyber analytics. Is the buzzword of today's. It's not future. It is the happening of today. Without conquering analytics, data science, little bit, you will not be able to conquer the cyber security in a meaningful way. Whatever we talk about is yesteryear's news about standard tools and bundled tools. They keep changing. We need to be aware of what I am talking today may be obsolete for in another 2 or 3 months when new challenges come in. So the technology keeps evolving. So is the challenges from cyber criminals and hackers. And therefore, we have another session. All participants, we have this an entry-level session where we want to enlighten what cyber security and the issues, all about that, for which we use these 14 sessions. And for the future, for the level 2, we are going to discuss the advanced level. Even that too is not fully advanced, at least on the current state of affairs. We have another FDP 2, the same title, level 2. Originally, we planned it for August, but they have a process. Level 1 must be over, and we have to submit all the documents. then they give level 2. So we are going to ask for a postponement, not in August 9 to 14, maybe another 10 or 20 days after. Whoever is interested to join level 2, you can express your opinion. There is a form raised to you, and you can indicate that. So we will let you know once that is notified, so that you can, because it is filled on a first come first served basis. I presume all those who have gone for level 1 can easily follow level 2. Even the people who are already in the field, they can directly join level 2. But ideally, for those who have undergone level 1, you can easily pick up level 2. So if you are interested to join level 2, please do indicate your interest. So we will intimate you as long as we notify it. Then you go and register in AICTE site, because it is filled on first come first served basis. 200 was over long back, but 140 participants only have come into. They have prevented another prospective 60 participants who are staying outside. They have registered, they did not come. So we want to make it focus, make it to be focused, and reach the resources to the right people. All these lecture materials are available on YouTube online, will be available online soon. We have uploaded, we are giving to AICTE. Once the accounts are settled, we will make it public, so you can revisit and learn it. Even if you miss level 2, you will be able to. But then the interaction sessions and question answer, it's a community togetherness. Within five days, you are focused and you will be able to learn something. Those things will be missing. With that note, I hope I can call it a day. And sorry, I will not be able to take much questionnaires, because it is going to be 1:30. You can post all your questions in your chat box. I'll answer them through your mail, and we will be back for valedictory session. Please make it. We will review, and we will have feedback, all that. Thank every one of you. Thank you.
Yes, sir. Thank you so much, sir. On behalf of our department and also participants, from the side of participants, thank you so much for your brainstorming session, sir. We have go for an in-depth knowledge in deep learning and also in cyber security. It would really help us, sir. It is really admirable, sir, how you are always having this in-depth knowledge, the way you are really inspiring and teach us, sir. We pray to have you, sir. Thank you so much, sir.
Excuse me, ma'am. Hello?
Yes, ma'am.
Am I audible, ma'am?
Yes, ma'am. Audible. Yes, ma'am.
Actually, I want to ask something, ma'am.
Yes, ma'am.
Is the quiz which will be held, it is like open book examination or something else?
No, the test is based on the materials that is already posted in our Google Classroom.
Yeah, that's fine, ma'am. But it is a